Large leading layers leave you lost until the simplest solution snaps into place. Solid sections spawn strange surface static, and flawless first layer followed by failure. All this and more, PrintFix Friday, episode 205. Let's get into it. Starting off with an interesting issue from GG Gamer over in the Bondtech Discord, who posted this Benchy. What do you think it is? Come on, put a comment down, let me know. Here are some other photos of it. We can see if you line it up just right, it looks pretty good. And that's the secret. They were having a little bit of fun and printed a Benchy on a bed slinger that was designed for a belt printer. I didn't even know that that was functionally possible, right? Because traditionally speaking, when it comes to 3D printers, you do not intermix G-code between printer types. Something that's for a Cartesian machine should not then be used on a Delta machine. Something designed for a belt printer should not be used on any other machine other than belt printers. But apparently it is possible, and it ends up with a Benchy that is at about a 45-degree angle or so, where every single layer is offset ever so slightly, which makes sense because that's how belt printers work. We can see here with some footage of a buddy of mine, Rob over at PrintFixFriday, who we've interviewed a couple of times. We'll card to the most recent one, where you have the actual belt system at an angle, and the entire print head itself is at an angle touching a moving platform. It is very different from your traditional 3D printer, but it enables for an infinite Y-axis, enabling you to do, well, really long things. We're going to be building a Baby Belt Pro here on the channel at some point in the near future. We're also going to be building one with some old heat beds that I've had laying around for a while. They're a little bit big. So we're going to be working with Rob and the entire PrintFixFriday team to make this Baby Belt XL Plus, I guess, where we're going to see a much larger machine. But this one certainly was one of those that just left you a little bit puzzled. Because when all I saw was this first image, I thought on a regular Cartesian printer, you would immediately tell the person to check to make sure the belt tension is correct and it's not slipping on the pulley itself. And two, you would tell them to check the grub screw on the motor as well. But in this case, all of those were perfectly fine. They were running code that wasn't meant for the machine. It was a bit of a test to see what would happen, and hey, as far as I'm concerned, that looks pretty darn cool. Let me know your thoughts down in those comments. And hey, while you're down there, don't forget to leave a like. And hey, my name's Grant. This is PrintFix Friday on 3D Musketeers, where we help you get your printers back to printing with purpose. If you've got some issues and you want to get our help, you can reach out to us on all the social medias, although our preferred method is to film a video on YouTube and tag us in that description, so we'll get notified of it. We can show it here on the channel. And I do want to give an update a little bit more to the A1 fire issues that we've seen in the past few weeks. We are now over a dozen confirmed cases of A1s that have had their metal oxide varistor blow. So if you happen to have that happen to your Bambu A1, and Bambu does not request that you return to your machine or anything like that, or especially the broken part, we would love to get those boards sent to us. We will cover all shipping and things like that. Our goal is to send them off to a professional testing facility to get them analyzed so we can understand why the failure occurs and present the data to Bambu Lab. We are also considering buying an A1 and doing thermal testing of our own. If that's something you like to see, let me know down in those comments, and please do subscribe because it does help the channel grow. But certainly moving from something that's a little bit tilted to something that's a little bit fuzzy. They're using an Ender 3 S1 Pro, and it's only fuzzy at the 100% infill areas, but it is perfect at the 20. This is indicative of overextrusion, and specifically for silks, something called dye swell. It's actually kind of common to see it with silk. When you have your printer loaded with silk material, just raise the hot end like 100 millimeters from the build plate and tell it to extrude 20 or 30 millimeters. You'll see the material come out and then suck right back up a little bit. That is dye swell. As the material is cooling, it is swelling a little bit. It is also created from the pressure from the hot end itself. I know that specifically dye swell is expansion right at the nozzle, but work with me on this. This is due to the TPU that is added to PLA to produce the silk effect that a lot of people know. I will say that 200C is generally a little bit cold, but that's not what is causing these issues. We are dealing with overextrusion. If you're dealing with issues on this part where it's just not strong enough and you want to go to 100% infill, you could instead just go to 80% and it would likely look just fine. You could look at tuning your extrusion multiplier, maybe dropping it 0.02 to 0.05. You could also run a steps per millimeter to make sure that when you are feeding 100 millimeters, that you get 100 millimeters. It's a good one to check as well. But when working on parts like this and you want them to be stronger, a lot of it can come down to orientation. Yes, a piece like this, there's really not a great orientation to print this and still keep the parts relatively strong. The best way that I could see printing it is to lay the part on this back edge of the leg. It doesn't look dead straight to me, but if it is, absolutely tilt the whole part up. And while yes, that will result in some support material, it will result in support material in areas where it's not that big of a deal. Areas like on the back of the legs. So I think you'll be okay there. Infill doesn't really provide any extra strength. Strength comes from contiguous perimeters. Infill, where it starts and stops, is nowhere near as strong. It provides some rigidity, but in terms of interlayer bonding, it doesn't really do as much as solid perimeters. So on something like this, you could just up your perimeter count quite a bit, and you'll be okay. But do look at adjusting that flow rate to make certain that you're getting the right amount of material extruded when expected. And while we don't have any personal experience running the EPLA silk magic from eSUN, we have experience making silk filament from scratch at Printed Solid, where we made Jesse's Elixir, a silver color, which I want to be called Silver Fox. If you want to see everything involved in making silk filament, we'll card to it so you guys can take a look. But I'd love to know if you've worked with the eSUN PLA Silk Magic before. Does 200 Celsius seem a little bit cold to you as well? Traditionally speaking, when you add a higher temp material, like TPU, mixed into a lower temp material like PLA, you're going to find that your temperature lands, well, somewhere in the middle, like a 220 instead of 200, and that should result in better layer bonding as well. Next up, with a user who has a Raft that is printing perfectly, and the actual print doesn't print at all. They've tried everything, and they're willing to completely start from scratch if someone wants to guide them. Hi, willing to help guide you. The thing with rafts is that they are printed very slowly compared to the rest of the part. This appears to be a Gen 1 Ender 3 just from the looks of it. You know, you can tell because of the way that it is.
You can tell that it's an aspen tree because of the way it is.
And if that is the case, you have to be careful about speeds. The Gen 1 Ender 3 doesn't have clipper or any fancy features. It is a bare bones 3D printer, and you can often find them brand new at $100 or less. Used, way less than that. Like, don't pay more than 25 bucks for a Gen 1 Ender 3. They're not worth it. When you see the user has tried cold pulls, changing filament, playing with E-steps, playing with flow rates, slicing and reslicing models, and the first few layers print fine, then it is Cobweb City no matter what it changes, and they're wondering if it's a ghost. There's a few different things that are likely going on here. For one, we can see that you do have a heatsink cooling fan. Make sure that the fins are not broken, that they are blowing in the right direction. You want it blowing air at the heatsink, not pulling air away from it. If this is a Gen 1 Ender 3, check the Bowden tube as well. These machines do not come with all metal hot ends, and therefore the Bowden tube goes all the way down basically to the tip of the nozzle. That Bowden tube, when it is heated, starts to degrade. If you don't replace it or at least trim it, you're gonna find that that ends up causing friction and printing problems. But one of the most common failure modes that we see in the original Enders is that the freaking bar on the extruder fails. So that bar is what provides pressure up against the tooth gear to pull filament through the extruder. It's made out of thin plastic, and the spring that Creality provides is way too strong for it. In fact, it's such a common thing. We can see that another user had a similar issue, and they found the spring wasn't anywhere near strong enough, so they crammed a quarter in it to give it extra pressure. When in reality, this bar right here is probably cracked and failed somehow. Please be careful and take a look at it. You want to be certain that that is not an issue. Make sure that it's not loose. Pull it off and actually take a look at it. They tend to break on the underside where they're not dead solid, and it's difficult to see until it gets really bad. If you do have to put a quarter or something else into it, that's not normal. You should not be adding that much extra back pressure to your extruder idler for it to grip your filament. Something else is indicative of an issue here. A great thing to do is check that Bowden tube. Some other things to check. We want to make sure the nozzle itself isn't clogged. A great way to check this is to bring the print head away from the bed, again, about 100 millimeters, and then extrude some filament. Watch and see what happens when the filament comes out of the hot end. Turn off all fans and make sure there is no airflow across that filament path. When the filament comes out, it should be dropping in a completely straight line. If it comes out and it looks like an S, you might have a clogged nozzle. Nozzles for Ender 3s are very cheap, and if your budget does allow it, we would recommend looking at upgrading to an all-metal hot end. While yes, Micro Swiss makes some amazing hot ends for Enders, they are on the more expensive side because quality manufacturing. And while yes, the generic all-metal hot ends from Amazon or AliExpress will probably work, I would not rely on them long-term. Those might be a bit of a stopgap until you can build up enough to afford something like that Micro Swiss. The nice thing is that Micro Swiss, assuming you have the same mounts in different printers, can be transferable to other Creality printers too. Just not any of the newer ones, because Creality finally realized that having a ever-changing ecosystem means that people always need to buy different pieces. They figured it out. But this can absolutely be frustrating, and something that, as a new user once before, I have been there. And I don't even remember exactly what my problem was. I just remember that eventually it fixed itself. It could be wiring and you have a slight issue with your thermistor, so your temperatures are fluctuating some. There are so many different things that this could be. But let's start with checking the fan, make sure that it's blowing in the right direction. Checking the Bowden tube to make sure it is clean, and if not, go ahead and replace it. You can get some cap tube for it, but even the generic Bowden tube works just fine. Check to make sure the nozzle isn't clogged, and then check to make sure that extruder isn't broken as well. With all of those things taken care of, and all of those are apparently just fine, then we can go a little bit deeper. So I'm going to offer one-on-one assistance with this user and do everything in our power to help them get their machine back up and running. Especially with these older machines, little problems like this can be so frustrating. Because they've been out so long, it's difficult to determine what actually is right and what is wrong. So if you're seeing this, hit me up. Love to help out. And hey, check those comments, because the viewers here are likely telling you other things that you should try as well. Last but not least, something similar to the previous fail, but a little bit different. We can see the user saying, why does my nozzle clog every other print? They've got a Neptune 4, and after the first layer, it pretty much clogs guaranteed. And before you say, well, look at the filament path. No, that's just an old photo where they tried to pull the filament out and it got a little bit bent. Don't worry about it. The temp is 215. And the speed is 250 millimeters per second with 40 on the first layer with Elegoo PLA+, and they've never had problems with it before. We can see the first layer looks great, but then it starts to degrade rapidly from there. Some things to immediately look at is going to be temperature. The problem with manufacturers, especially ones where you don't have the most reliable customer service, is that if they change master batches, if they change suppliers, if they change raw material, things can change on your end and you wouldn't even know it. The best thing to immediately start is to try a completely different roll from a different brand and make certain that it is not just one bad roll. Recently, we threw out a roll of filament for the first time in years because of issues with the material. Came from a really reputable manufacturer that we have direct contact to, and it spurred an entire investigation and eventually a change in their main supplier. That is customer service, because they're pushing something that will make their material better. And I could not be happier as a user, even though I had to throw money away, because that's a solution to a problem, not a continued problem with no solution. Some other things to check with the Neptune 4 is the speed itself. When you do print fast, 250 is quite fast. 215 degrees Celsius might not be hot enough for that material. And whether or not the machine can keep up with that temperature doesn't mean that the filament can extrude at that speed at that temperature. So you need to be careful with that as well. Similar to the last issue, we will want to verify that the fan that is cooling down the heatsink on the hot end is 1, spinning, and 2, pointed in the right direction to make sure that it is getting cold air where it needs to go across the heatsink to keep it from heat creeping. The Neptune 4 does not suffer from poor cooling like the Gen 1 Ender 3 does. In fact, it has this massive rear blower system that just has a huge curtain of air going across the print, which does actually help more in one direction than others. So if you do have an edge that has a tendency to curl, if you face it toward those fans, it'll be a little bit better than normal. But if this is happening consistently, even with other brands of filament, we can remove the filament as the issue and look toward mechanical, electrical, or temperature-based problems. Mechanical is not something I would immediately be looking for, unless it could be a clog nozzle that the machine is able to push through when you're going much slower, but when you go much faster, you might not have the extruder pressure. The next thing to check is the actual extruder pressure. Is it high enough? Is the extruder actually latched down, or is it stuck kind of in a half on, half off scenario, as they can sometimes do? But we can mess around with temperatures and see if that makes things any better. And if all else fails, I would check to make sure that your heater and your thermistor wiring are all in good shape. Traditionally, when we do a very slow first layer and a very fast second layer, we make certain that the ramp-up temperature occurs with enough time for the machine to get up in temperature before it needs to start moving fast, which generally means we overheat the first layer by quite a bit, so that the second layer, when it does move much faster, is much closer to its target temperature and has a lower likelihood of actually failing out the print due to thermal runaway, because the heater can't overcome the amount of filament that's being pushed out of it. I would also check to make sure that your print settings are accurate on this. Neptune 4 running at 250 millimeters per second is very fast, and I think much faster than the stock hot end can handle. So I would check to make sure, let's say you drop the speed to 150. Do you still have these problems or not? That can lead us back to, well, it's temperature and it's the extruder in those orders. But if all else fails, go ahead and replace the nozzle. It's not going to hurt it. Having some spare ones on hand is good too. Make sure you follow proper recommendations for changing out the nozzle. I forget if the Neptune 4 can have a nozzle or if it is a whole hot end swap, but knowing that it's Elegoo, the prices for their components are not expensive, and OEM is not going to cost you much more than an aftermarket. And so my thought on this is that it's likely a temperature-based issue with a extruder pressure and potentially a clog nozzle, all mixed into one, with the caveat of it could just be the heatsink fan and it's heat creeping. What do you all think? Let us know in those comments. And don't forget, we are still seeking A1 power supply boards that have had the metal oxide varistor fail on them. If yours has had that and you have that board laying around, please reach out to us via email. We would like to go ahead and get them in so we can get them sent off to a professional facility to get them tested. Again, if you do want us to get an A1 and test a current A1, I guess I'll go ahead and order one, but it'll be with a burner email and to an address that is not associated with this channel. Because, you know, we want to make sure everything is done right. Speaking of getting done right, the names listed right next to me at the $5 tier and higher make it so we can do things like that and be able to make videos like this. If you do want to support the efforts that we do here, you can do so by joining for as little as $1 a month in those links down below. And at the $10 tier and higher, you get to come hang out in our super secret Discord, where we talk about things like this very openly, very frankly, and are starting to gather what we believe could be a potential failure for things like the A1. You get one-on-one support as well, which is always a lot of fun. That is all we have for you all today. Hope you've enjoyed this episode, and don't forget, 208 is around the corner, and that's going to be Grant reacting to mean comments. I'm not saying to deliberately troll, but if you happen to find any, shoot them over to me, put them in the Discord so we can see them. We've been collecting mean comments for a while, so it'll be a lot of fun. But stay safe out there, don't forget to call your loved ones, and as always, keep making awesome. Have a good one.